All right, class, we're going to talk about conservation of energy and how energy can be transferred from one form to another, but it's never lost. We've talked about the law of conservation of mass, how mass cannot be created or destroyed. We've talked a little bit about how energy cannot be created or destroyed. This section is talking about how that transfer happens. So right here, energy cannot be created or destroyed. It can only be transformed or transferred from one form to another. One of the examples that this section talks about is a transfer from potential to kinetic energy. So if you have a pendulum, like the pendulum on a grandfather clock, right? It sways back and forth. Or a roller coaster, or if you're on a swing. When you're at the height of the highest point of that path, you have the most potential energy that you would ever have. And then at the very bottom, you have the most kinetic energy, okay? Because your potential energy would be the least. And as you rise in height, your potential energy increases while your kinetic energy decreases because you're slowing down. Okay, kinetic energy has to do with your speed, where potential energy has to do with your position. So as your potential energy decreases, your kinetic energy increases. And then as you go up, yeah, opposite is the same. Okay, a roller coaster. When you're at the highest point of a roller coaster, you have the most potential energy. Okay, but you're probably going the slowest, so your kinetic energy is really low, or you probably have a little bit, but not much. But then as you start to go down the roller coaster, your kinetic energy increases because your speed increases, but your potential energy decreases because your height relative to your lowest point decreases. So that transfer is happening all the time. Okay, another thing that we need to make sure we're aware of, it cannot be created or destroyed, but sometimes, and we say it's lost to things other than mechanical energy, but it's not really lost. That energy is just transferred to sometimes heat energy. The roller coaster will start to heat up the track a little bit because of the friction of the wheels on the track. You lose, or your energy is transferred to sound energy. You have air resistance that happens. So all that energy is transferred to different things other than mechanical energy, and mechanical energy has to do with motion. So it's not lost, it's just lost as according to mechanical energy, okay, or ways for you to make that object move. Okay, I'm gonna include some pages from your book in this. The law of conservation of energy is in there that I'm gonna actually include. But I want to talk about efficiency. Okay, efficiency is how useful or how well your machine works. We've been talking about compound and simple machines. Okay, efficiency is the useful work output divided by the work input. Okay, the input is what you actually were going to physically do. It could be how much electricity is, if you have a heater, how much electricity is sent to that. If we're talking about a simple machine, it's how much work we're actually physically doing, okay? Where the useful work output is how much we get out of the machine, okay? Let's say I have a heater in your house, okay? There's some that are 85% efficient, 90% efficient, or something like that. That means that of all the energy that goes into that machine, you get out 85 or 90% of that. There's some energy that's transferred to just making that machine work. Okay, you'll never have a machine that's 100% efficient. Okay, you'll always have friction. You'll always have things that make that machine work. So if you get you're gonna get a decimal, okay, which we're gonna turn that into a percentage, but that number should not be more than 1. If that number is more than 1, then you've probably done something wrong. Maybe you put these upside down or something like that. Okay, an example from your book. It says, when you do 100 joules of work on the handle of a bicycle pump, the pump does 40 joules of work pushing the air into the tire. What is the efficiency of the pump? Okay, 100 joules is what we actually, the work we did on the pump, and 40 joules is what we actually got out, okay? So the output, the useful work output is 40 joules. The work input is 100 joules, and that equals 0.4, okay? And then as a percentage, that's 40% efficient, okay? Again, energy can be transferred from one form to another. It can never be lost.